again to Late Night Tea with Dr. G. Go get your cup of tea, cup of cocoa, and grab your FAR aim and your highlighter, and let's get ready for takeoff. So I'm not going to teach you how to fly an instrument approach, but I am going to help you decode an instrument approach procedure. IAPs, often referred to as JEP charts, or approach plates. So let's get started. Tea time, tea time. And water. Okay, so this is a Nashville approach. It's an ILS or localizer into runway 2 left. ILS stands for Instrument Landing System, and an ILS is a precision approach because it has an electronic glide slope that provides that vertical guidance. A precision approach, remember, brings you to exact alignment, center line of the runway, on the runway. A localizer option is also for this approach, and that is if your glide slope is inoperative, you can still shoot a localizer, which is a non-precision approach. It only provides lateral guidance, not vertical guidance, because it lacks a glide slope, an electronic glide slope. So I want to start on the top part. You read it from the top and go down to the bottom, and the top is your communications box. That's this area right here. And I'm just picked a few things that I want you to learn, and first one is what the ATIS is. ATIS. So let's look that up in our pilot controller glossary in the back of your FAR aim. You will first find the acronym, and then it will spell out what that what it is, so you can actually look at the definition. So ATIS stands for Automatic Terminal Information Service. So now find that definition and highlight it when you find it. Okay, it says Automatic Terminal Information Service is the continuous broadcast of recorded non-control information in selected terminal areas. Its purpose is to improve controller effectiveness and to relieve frequency congestion by automating the repetitive transmission of essential but routine information. So when we're in the aircraft, guys, we dial into, for this one, 135.1 is different for every airport, right? And it will let you know the active runway, the winds, the density, altitude, the altimeter, visibility, and all that information. And that just allows, so that the controllers don't have to say all that information to each pilot. So it's just kind of a continuous loop. While I'm not on the airplane now and I can't dial up ATIS, I can dial up ASOS on my cell phone for you guys, so you can kind of get an example of what it would sound like. And ASOS is Automatic Surface Observing System, and this is for Nashville.
Nashville International Airport. Automated weather observation 0455 Zulu. Wind 030 at 05. Visibility 10. Sky condition Q600. Broken 3,900. Overcast 5,500. Temperature 17 Celsius. Dew point 14 Celsius. Altimeter 2997. Remarks. Density altitude 900. Nashville International
Then
Airport.
it starts over again,
Automated
right?
weather observation 0455 Zulu. Wind 030.
Okay, the next thing I want you to know is what this number means inside that circle. It says down here, this is the MSA for BNA VOR. So MSA, let's look that up in our pilot controller glossary, and that stands for minimum safe altitude. BNA is your Nashville identifier, and VOR is your nav aid. It's your very high frequency omnidirectional range. All of these acronyms can be found in part 1 of your regulations or in the pilot controller glossary. And it gets easier with time, guys. The more you hear it, the more it becomes second nature. So look at minimum safe altitude. And I want you to look under Bravo 1. And it says minimum safe altitudes are altitudes depicted on approach charts, which provide at least 1,000 foot obstacle clearance within a 25-mile radius of the navigation facility, waypoint, or airpoint reference point upon which the MSA is predicated. So this one is over the Nashville VOR. What that means is your minimum safe altitude is 3,100 feet. And as long as you don't fly below that, you have at least a 1,000 foot clearance from everything, from all the traffic and any terrain. It does not ensure nav reception. It's just your minimum safe altitude. Sometimes and the radius is 25 nautical miles. Sometimes this is divided up into sectors. Maybe it'll have like a west quadrant or north, and it'll have the radials, and there will be different numbers in those sectors based on the terrain or any obstacles. And so that if that occurs, then those are actually called minimum sector altitudes, which is also in your glossary if you wanted to look that up. It's kind of right below there. The next one I want you to know, guys, remember that an ILS, part of it is two of the components of an ILS are going to be your localizer and your glide slope. So remember in the localizer is an antenna, and then the glide slope has an antenna, and they both transmit a signal. You tune into that in the aircraft and you fly the approach. The localizer identifier always starts with the letter I. So the localizer identifier is India Bravo November Alpha for this approach, and the frequency is 109.9. That is the localizer frequency. You can see it's also right here telling you that the ILS DME is 109.9 for IBNA, and there's your Morse code identifier. In order to shoot the approach, the radial that you'll fly is 021 degrees. That's your final approach course. And your glide slope, which provides vertical guidance, will occur at the Dobbs intersection or the Dobbs fix, which is right here. You can also see on the profile view. And that's just where it is on this approach. Every approach is different. But the glide slope will begin there. That's where you will begin. That's where you'll intercept the glide path or the and actually start your descent, right? The numbers in bold here are going to be altitudes in mean sea level, and the numbers in parentheses are in above ground level, AGO. So your glide slope is going to occur at 2,500 feet at the Dobbs intersection or Dobbs fix, and then 1,901. It's the same altitude, it's just AGO. Your ILS decision altitude and height, I have not taught you that yet, but in a little bit we'll learn that that 799 is your decision altitude, which is also down here in the minimums, and 200 is your decision height. Your airport elevation and your touchdown zone elevation is the same, and that's not always the case. Sometimes there is a 1 or 2% up or down gradient on your runway, but those are both 599 feet. And then I want us to look at the plan view, which is going to be the middle portion here. And this is as if you're flying over the airport, right? And you're looking down, the bird's eye view. I want you guys to see, that there are 3 parallel runways in Nashville right here. 1, 2, 3. And this is an intersecting runway 331. Which you can look up all the information about an airport in the supplement data, which is used to be called the Airport Facility Directory, an AFD, if that sounds familiar. But now I think they're called supplements, and they're on the FAA website, and it'll give you all the information you need about the airport. So what I'm wanting you to see here is that this is your Nashville VOR. Remember, VOR is a very high frequency omnidirectional range, and it's a navigation equipment on the ground, and it sends out a signal in all directions, so 360 degrees. You tune into the VOR, and you either fly to the VOR or you fly from the VOR. This is called, this right here, this compass rose is indicating the VOR. And then this is our Nashville VOR. The 114.1 is what you would dial into for the Nashville VOR. And the only positive method of identifying a VOR is the Morse code, which is located here. The dashes and the dots sound different. Beep, 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 like that. So that's your Nashville VOR. There's more information on there, but I'm just kind of going through some of the basics with you. The next part I want you to look at is your profile view. So up here is your communications. This part is your plan view, and this part's your profile view. Since this is an ILS or a localizer approach, that means there are two paths that are presented in the profile view. Profile is your side view, right? So this same glide slope, this same feather right here, see how that's showing it going in right here with the inner marker? That's the same information, just a different way to look at it. See, you have your FIDS here, FIDS, Dickens, Dobbs, TP, so the same points are along the path here. Okay, so what I want you guys to see is we have this black solid line. And you can see that there's a black solid line. And then right here where this Maltese cross is at Dobbs, there is also a dashed line. Which one goes lower, the solid or the dashed? Correct, the solid line. So the solid line is more precise. It brings you down to the lower altitude before you have to decide, do you have the required visual reference? And if you do, continue the descent and land. And if you don't, execute a missed approach. So because that is more precise, the solid line is going to be your precision approach, which is your ILS. So this line right here is your ILS path. Right here is your localizer path, which is your non-precision. Next, I want us to look up what FAF is. So I want you to go to the front of your book, 14 CFR Part 1, Definitions. And I want you to look up and highlight Final Approach Fix, FAF. FAF says it defines the beginning of the final approach segment and the point where final segment descent may begin. So before this point, let me back it up. We're at final approach course is 021 degrees. We're at 4,000 feet right here. We get to the FIDS intersection, FIDS affix or point. The D is your DME, so your distance is 12 miles from the Nashville localizer. And then we're still flying the same straight in, right? 021 degrees. But then we're going to descend down to 3,000 feet past Dickens at 8.8 nautical miles. In between these 2 points, guys, in between these two fixes is at 3.2 miles. And then the next one from Dickens to Dobbs is 1.6. And we're now at 2,500 feet. We begin the final approach descent and our glide path right at the Dobbs point right here, the Dobbs intersection. Inside this feather, guys, is your final approach fix for the ILS. So it looks like this, right? We've got our feather and here's our runway down here. Inside the feather, inside this V, that is your final approach fix for the ILS. That is where you begin your final approach descent. Now remember, we have an ILS and a localizer option. In case your glide slope's out, you have to shoot a localizer. The localizer's final approach fix is also going to be at the same place because it's where the Maltese cross is at, but it is not always at the same location. That was just coincidence. So the Maltese cross is where your final approach fix is. Inside the feather, final approach fix for the ILS. The Maltese cross could be further in. Do you see what I mean? Or further out. So it just depends on whatever that little cross is. It's called a Maltese cross. That is your FAF for the non-precision localizer approach. That's where you begin the descent. Here's our glide slope. It's where we intercept our glide path, begin our glide path, right? We're going down we're descending 021 degrees still. Remember, along this path, we'll have our marker beacons that gives us indications of our range information, our outer marker, middle marker, and if it's a Cat 2 approach, an inner marker. So as we're descending, I want us to look at the points where the arrows go up. So remember, the black solid line is your ILS. Where the line goes up, that is where, if we do not see what we're supposed to see, the required visual reference, we are going to execute a missed approach, which means we basically get out of the way and we try again. But we don't just do anything. There are set procedures I'll show you in a minute. So I want us to look up what the missed approach procedure means, or missed approach point, I mean. So go to the back of your book, because sometimes they're not in the definitions. It's in the glossary. And look up Missed Approach Point, MAP. And then highlight it and read it when you find it. This is a lot of information, especially if this is brand new to you. So you might have to read over it. You might have to think about it a little more and study it. It is a lot of information to learn. So be patient with yourself. Okay, missed approach point. It says it's a point prescribed in each instrument approach procedure, which is an IAP, like what we're looking at which a missed approach procedure shall be executed. What does the word shall mean? Yep, shall means must. It's an imperative. It says that it shall be executed if the required visual reference does not exist. So the required visual reference, guys, there's an actual list of what all that is, but it's something very specific to the runway. So it's your runway lights, your touchdown zones, your centerline lights, your runway centerline markings, something very specific to that runway, not just the airport environment, right? We're trying to land on a specific runway. So if you get down to that point and you do not see what you're supposed to see, then you do not continue to land. You will execute a missed approach. This point specifically on this approach is at 799 feet. There are 2 places it says that. It's called your decision altitude, where you'll make the decision. Do I see what I'm supposed to see? If I do, cool, continue to land. If I don't, execute a missed approach. When you execute a missed approach, you will follow the published procedures and you will enter into what's called a holding pattern. And the procedures are up here as well as right here. There's just 2 ways to read it. And then this only has one missed approach procedure and holding pattern. And I'll explain that a little more in a minute. I want to also talk about the missed approach point for the localizer. So remember, the localizer is your dashed lines. You can see the line is higher up, so it's not as precise in case you ever forget which one's which. And then where the M is, that is your missed approach point for the localizer. You'll get to this one is 980 feet mean sea level. That's your minimum descent altitude. If you're flying, you'll get to that point. You'll look at the altimeter at 980 feet. If you look out and you do not see the required visual reference, you don't see your touchdown zone lights, your runway markings, thresholds, something like that, execute a missed approach. Do not continue to land. How do you execute a missed approach? Well, it's published. It says up here. So look. Here's our path also. We're shooting the approach. We're on our glide slope, our glide path. We pass the inner marker right here, which is also right here, inner marker. This is generally where we make the decision. Do I see what I'm supposed to see? So let's say we don't. We do not have required visual reference. This is what we're going to do right here. We're going to go here and we're going to hold. So specifically, we're going to climb to 1,200 feet. And we're going to turn what direction? Left, right? So here, climb, turn left. And then it says, go to 4,000 feet. On heading 240, okay? 240. Outbound, the VOR. The Nashville VOR, the R is your radial, 270. So see, here's the Nashville VOR. And you can see here, this would be your 270 radial. So you are flying 240 until you get onto that outbound radial. Outbound the radial 270. And it says go to the BV intersection. BV, this open triangle is your intersection here. This is called a non-compulsory point. I want you to know that, a non-compulsory point. When it's an open triangle, it means you do not have to report your position at ATC. If the triangle is blacked in, colored in black, it is a compulsory point and you must report your position to ATC. So you go to BV intersection, the distance, the DME is 22.4 from Nashville, and you hold. And we don't just hold, we can't just stop airborne, but they mean you enter the holding pattern, which basically means you continue to fly what we call the racetrack until ATC, air traffic control, lets you back into the pattern with appropriate sequencing and then lets you attempt your approach again. And it depends on how much fuel you have, on how many times you can attempt this, But you do need to know in your mind, you need to have a game plan on how many times you can attempt this before you need to think of an airport to divert to and safely land. If you can't, you try 2 times and the cloud layers are just too low, the visibility is too bad, and you simply can't see, guys, you're not going to land. If that's dangerous. Don't get in a rush. Don't do something unsafe. And there are accidents that have happened from that, and there are fatalities from that. So if you get to that point, you might be ready to get home. You might be worn out. But guys, if you don't see what you're supposed to see, you've got to execute a missed approach. And if you don't think you have enough fuel to attempt that, several more times, and it doesn't look like weather's clearing up, you got to go ahead and come up with a backup plan, right? We got to divert somewhere, safely land, wait until weather clears up. Also, this is a missed approach procedures down here. I personally like reading it better, but you might like the pictures. So see, look, climb to 1200, turn left 4,000 feet on 240 heading. And then this is the Nashville frequency for the VOR 114.1 because you're going outbound radial 270. And then these are your holding procedures. So I'll ask you on the test about how to execute a missed approach. So I want you to tell me the actual procedures, and I'll also ask you what is your holding procedure, and that is different, right? That's going to be over here. This is your holding procedure for this one. Okay, let's look at, so now I want to talk to you about the bottom part, the landing minimums. So the landing minimums are based on 2 factors. First thing I want you to know is these are called landing minimums because you have to have these minimums in order to shoot the approach and land, unless you're in an emergency, of course. So the minimums are based on 2 factors, and I want you to remember this as we go along, because I have to teach you what all this means. So it's not going to make sense for just a little bit. So stand by. You're in a holding pattern. So there's 2 factors. One is going to be your decision altitude and height, which that's going to be based on your cloud layers. And then the second factor is your visibility. Before you take off, so let's say we were going to go, let's say we were in Miami and we're flying to Nashville. Before we take off from Miami and fly to Nashville, we would have to look up the Nashville approach that we're going to use. We would pick the most favorable approach, and we'd make sure that we have a headwind to land with, ideally. We want headwinds for both takeoff and landings, right? Headwinds for takeoff and landing are ideal and are favorable, and if it's available, we actually have to do that per the regulations. Sometimes we have a tailwind and we are allowed to take off and land, but there are aircraft limitations for that. A headwind, when we land, it's going to increase our drag and it's going to reduce the amount of landing distance required and help us stop. So that's why we want it for landing. So before we take off from Miami and fly to Nashville, we actually have to figure out what time we would get to Nashville, which is our estimated time of arrival. Then we would look at the forecasted and the observed weather, and we would see where the cloud layers are at, called our ceiling, and we would look at our visibility. And we would make sure that we at least have what is published in these minimums. These aren't called landing maybes, these are called landing minimums. This is the minimum you have to have in order to fly to that airport. Now, if you get there and the conditions change and they're less, as long as you feel it's safe and you have the visual reference, you may shoot the approach, but we can't take off and fly there if the weather looks like we're not going to be able to make it. And that doesn't even make sense anyway, because we wouldn't want to, spend that time and money and fuel cost money, operating costs, going somewhere that we know we're going to have to divert. So these minimums, guys, we just have to be at them, at these numbers or above. We do not have to be above it necessarily. Just straight at it is good, is what I mean. So, for example, how old in the U.S. do you have to be to drink alcohol? That's right, you have to be 21 years old. Do you have to be above 21? No, you just have to be at 21. So anytime in the regulations there is a minimum and it says you have to be at the minimum, it means at or above is good, but below it would not be allowed or authorized. Okay, well, we've gone over the basics of decoding an instrument approach procedure, and the next video is going to go over more details on decoding the landing minimums in regards to the aircraft approach categories, the RVR, decision altitude heights, minimum descent altitude heights, and all that good stuff. Have a wonderful day, wonderful night, and I look forward to seeing you on my next video. See you soon.